Friends, today we will discuss a special question of exercise 5.2 that prove the function fx which is given by x minus 1 mod for x belongs to real number is not differentiable at x is equal to 1. So we have to check the differentiability at x is equal to 1 and we have to prove that it is not differentiable. So this type of question in which there is a sign of mod or sign of a box, that is greatest integer function, then to check the condition of differentiability we have a special rule, that is for left hand derivative at x approaches to a, which is we always write fx minus fa upon x minus a. So in this we put x is equal to a minus h as h approaches to 0. So this derivative after putting these values will become limit h tending to 0 f a minus h minus fa upon, when we put x is equal to a minus h, a minus h minus a will cancel, will get only minus h. So this is the left hand derivative at a. Similarly for right hand derivative we have x approaches to a as we have the concept fx minus fa upon x minus a. Here because x approaches to a plus means you need to put x is equal to a plus h, and as x approaches to a, h will approaches to 0. So h will approach to 0. So here it will be x is equal to a plus h minus fa upon h. So these are the value of left hand and right hand derivative. If these two things are equal, then only we can say a function is differentiable. So how to check this for the given question? Now for the given question we have to check the left hand derivative, which is x approaches to 1, it is fx minus f1 upon x minus 1. Left hand derivative x approaches to 1 from left hand side. When we put the values, it will reduce to h approaches to 0. Here it will be f1 minus h because a is 1 in this question. We are checking the derivative at 1. So it will be a replaced by 1 minus h minus f1 upon minus h. So to compute this limit h tending to 0, we have the function 1 minus h minus 1 because the x is here 1 minus h, and f1 is, when we put in this function, if we put x is equal to 1, it will be 1 minus 1 0 and mod of 0 is 0. So this value is 0 and denominator is minus h. What this is left with? 1 cancel with 1, minus h mod is just h upon minus h is minus 1. So this is our left hand derivative. Similarly right hand derivative we can find this. It will be f1 plus h minus f1 upon h. That is the definition that we have written here. We just replace a by 1. So now what will this term be? It will be 1 plus h plus minus 1 mod minus 0 upon h. 1 will cancel with minus 1, we'll get h. Mod of h is just h. H upon h, limit h tending to 0, it is 1. So you can see the left hand derivative is minus 1 whereas right hand derivative is 1. Left hand derivative is not equal to right hand derivative, therefore not differentiable at x is equal to 1. This function is not differentiable. The next question, which is the greatest integer function, which is fx is equal to box x. Box x means the integer which is just before x. So here it is the greatest integer function. We have to check the differentiability at x is equal to 1 and x is equal to 2. Here we are going to check at 1. So left hand derivative, as I have already told you the definition, limit h tending to 0 f a minus h. For left hand derivative you write here a minus h, and in denominator also you write minus h. Other values are same, minus f a. A is the point where you have to check the differentiability. To here that point is 1. So if we put a is equal to 1, we'll get f1 minus h minus f1 upon minus h. What is f1 minus h? fx is box x. So f1 minus h will be box 1 minus h, and f1 is box of 1. So you can write box of 1, which is already integer, so its value will be 1. But 1 minus h in this real line, it is 0, 1, 2, and here it is minus 1, minus 2. Our quantity 1 minus h, 1 minus some small number h. H is very small number. So when we subtract h from 1, the quantity will be less than 1. And what is the integer? Just before this, so before this the previous integer is 0. So value 1 minus h is 0. And value of 1 integral box is 1. 0 minus 1 is minus 1 upon minus h. And as h tending to 0, something upon 0 is infinity or does not exist. So this limit does not exist. It doesn't have any finite value. So left hand derivative does not exist. Similarly, now we have to find the right hand derivative, which is the definition. H approaches to 0. F a plus h. For the right hand derivative you write here a plus h and positive h in the denominator. Minus f a as it is. Now a is 1 in this case, so we replace a by 1, and the definition of function f is box of 1 plus h and box of 1. Box of 1 is 1 and box of 1 plus h means the integer which is just before 1 plus h. So 1 is here, 1 plus h will be here, very small number h. When we add it to 1, so it will be just greater than 1, and the previous integer will be 1. So the integer just came before 1 plus h is 1. So this is 1. Box of 1 is also 1. 1 minus 1 is 0, and 0 divided by any number is 0. The limit of 0 is 0. So left hand derivative is infinity, right hand derivative is 0. Both are not equal, or you can say left hand derivative does not exist. That also give us the result that the function is not differentiable, because for differentiability we need both the derivative left hand as well as right hand derivative to exist and equal. Thank you.